Hello everyone, it's May 19th. And again, an early one. I'm kind of getting used to this early thing, like first thing, second thing in my day. So just get the day going. All right, let's take a look. Oh, we have one response, probably nothing of, yeah, I don't know what that is. All right, take a look. Minimum moves to equal array elements 2. Have I done a 1? I don't remember. Given array, nums of size n, okay, return the minimum number of moves required to make all array elements equal. In one move, you can increment or decrement an element of the array by 1. Yeah, I think I've done something similar, but that's not like by 1. I think he's increment by 1 and divided by 2, something like that. This is just increment and decrement by 1. 2 moves are needed. Increment by 1, decrement by 1, okay? Oof, 16. I mean, it asks for the minimum, right? The minimum number of moves. I mean, the maximum, the moves always, like, if we pick the maximum value and everybody just go to the maximum value, that will include 9 plus 8, that's 17, that's 18. 18 moves. So we have a higher bound. Well, actually, we can also move everybody down. Like this will be 9 plus 1 is 10. It's 18. Is it the same? Is it the bound? Is the bound the same? That's an interesting question. If I find the max and everybody would converge to max, no, I don't think it's the same. Because the only same is the max converge to the min and min converge to the max is the same, but everybody else is not the same. Like if I have 1, 1, and 10, right? If I want to 1 and 10, 1 and 10 will be the same. 1, 2, and 10, right? 1, 2, and 10. And I converge to max will be 9 plus 8. If I going back down to 1, that will be 9 and 1. Yeah, that will be different. Right? It's different. But of course, we don't go to the max because it's likely somewhere in the middle will give you a better solution. Somewhere in the middle, we don't know, right? Let's say we want to get to just the median, right in the middle. So 1, 10, 2, 9. Let's say it's get to 5, 5 or 6. Let's say we want to converge at number 5. Then 1 will have to move 4, 10 will have to move 5, 2 move 3, 9 also move 4. So that will come up to 4 plus 5, 9, 12, that will be 16. That's a 16 move. What if we do 6? That will be 1 move 5, 10 move 4, see that's the same, 2 moves 3, and 9 moves 3. Isn't that 15? I think I probably got it wrong somewhere. Like, what converge to 6? 1 need to move 5. 10 need to move 4 because 10 minus 6 is 4. 9, 8, 6, 4, right? Not 9, 8, 6. Oh, hold on. How many moves? Yeah, how many moves is just difference, right? 9, 8, 7, 6. That's 4 moves. 6. Oh, it will be 4. 2 to 6 is 4. And then 9 to 6 is 3. So this added together is also 16. So if we pick some value that's in between, right? In between, then no matter how we move, it's going to be the same. Like if we pick anything in between 1 and 10, the number of moves is the same because that's just going to be n minus 1 plus n minus 10. No, n minus 1 plus 10 minus n, right? So n minus 1 plus 10 minus n is always going to be 9. And then if that value is also between 2 and 9, that's just going to be n minus 2 plus 9 minus n. That's going to be 7. So That's 7 plus 9. That's 16, right? So the only difference is if we go lower. We go somewhere lower, right? If we go somewhere lower, then you can argue if we go somewhere lower, then one side will have to go much more than the other side. Yeah, so like if we plot them out, right? If we plot them out, let's say just on one axis. So we have 1, we have 10, we have 2, and we have 9. And I think it is just like if we go in the middle, that will be the minimum number of moves. Because if you go outside, like we go outside, then what will happen is if we go outside, then it will be more. Yeah, then because if we have a value, let's say a value is outside the range of 2 to 9, and then in order to get to that value, let's say it's a large value, then 2 has to cover 7, like 2 to 9, plus whatever it has to cover in addition, and 9 has to cover in addition, so it will be more. So the minimum that you can move 2 and 9 will be just in the middle, right? And the minimum you can move 1 and 10 is also be in the middle. So I think the way we want to find is lay out the entire number, right? Lay out the entire number. We find the middle, right? We find the middle of everybody, and we just start to, so we find the middle, and the sum of the values at either side of the middle value, we sum of them up, and if it's an even number of elements in nums, and that's it. If it's the odd number, we need to pick, oh yeah, if it's the odd number, we pick the odd number in the middle. If it's the even number, so it's the same. It's the same because the odd number we don't have to move, we just pick the value in the middle. And if it's the even number, we just pick whatever is in the middle. So what we need to do is sort it, all right? We're going to sort the value and sum from both sides in. And that will be it. Not sum both sides in, sum the difference, right? The difference, front and back, and then sum the difference. Okay, so let's code it. I mean, I don't see too much difficulty in coding this pretty straightforward logic. Yeah, and I think the analysis is right. So basically, I can see this one. You can consider this one as like a kind of greedy solution. Yeah, I think this is greedy. This is like greedy, but we have a proof, right? It's greedy, but we have a proof. So let's find it first. So first of all, nums.sort. Let's not use extra space. And after we sort, we're gonna get rest gonna be 0, and front and left and right. So left and right equals 0, and len nums -1. While left is smaller than right, because we don't want them to meet in the center or cross. Then rest plus equal to nums left plus minus nums right minus, and then return the rest. All right. Okay, so now we have to run some test cases. We only have 2 test cases, but I think that should be sufficient for this purpose. Just to double check, like the idea is correct. Yeah, I think the idea is correct. It's going to be nums, and then this is going to be min moves 2. That's also going to be nums. Wait, something is not right. Am I running? Oh, shoot. I forgot to increment. It happens all the time. All right, now we good. Yeah, I always complain about. Yeah, set it pretty strict. Oh, about this, I find some good library yesterday that I think it's worth sharing. Oh, it didn't test any edge cases, but it passed. So I guess we don't have to test any edge cases. All right. So the idea, right? It's a greedy solution. We sort the numbers, and we want the final converging value to be in the center of nums. Given two values, right? Given two values, it is always uh, better to converge to a value in between them than outside of them. This is because any convergent value between them will require, let's say, given two values, a and b, right? Let's do a and b. It is always better to converge to c such that a smaller equal to c smaller equal to b, right? And then we can say, I think we have to use this. This is because any convergent values, any c, this is because any c will lead to the number of moves being b minus a. If we converge to a value outside, such as d larger than b or d smaller than a, then the number of moves will be b minus a plus d minus a plus b, right? D minus a, no, it would be d minus a plus d minus b. So we're going to use this because d could be smaller, which is always larger than b minus a. Therefore, for any pair of numbers, the best strategy is to converge to somewhere in between them. Considering the entire list, entire nums list, the best strategy will be to converge to a value in the middle of the list. If there are even number of elements, right? Even number of elements in nums, the convergent value doesn't matter. Just somewhere in between the center pair. If there are odd number of elements, a convergent value would be the median. However, neither of these cases matter in terms of the total number of moves, which will be the sum of all the differences from the end of nums, from the last element, from the differences between the end and start of nums. So we're running O n log n because we sorted, and this is give us 76 milliseconds, which is a 50% ranking, which is just like regular. This is a regular performance. Okay, go back, see the solution. I think this probably is the standard solution. I gotta finish it fast. I'm hungry. Solution is locked, so we just go to see people's comments. Come on. Probably easy. Gives a median. This is, oh, we haven't done it. We haven't done it. It's fine. All right. That's a decent question. 462. Right? It's going to be LeetCode 462. I see Parkman. Meeting point, 2 lines. Can you do this in 2 lines? Yeah. Hold on. How do you do in 2 lines? In 2 lines. So we need the front and the back, right? So we can reverse it. We can reverse it, and yeah, something like this. I'm not gonna put it here. Let's try. It's always intriguing, right? Oh no, what are you doing, man? So what we want is, so we're gonna, but you have to sort it. Okay, so first line is to sort. Second line is after we sort. So we're gonna say for front, for left, and right. And we're gonna zip it, right? And zip it and divide by 2. So zip nums minus 1, and we'll say right minus, oh, then you have to do ABS, left minus right. All right, ABS minus right, and then I'm gonna sum this whole thing, right, and divide it by 2. Now we're gonna turn this necessarily convoluted. So this is just I took the challenge to do it in 2 lines. Let's see. Is that his way? Not sure. Sum. Oh, look at that. Oh. Okay. Okay. Yeah. All right. All right. Yeah, this is good. This is not, right? What is this? I forgot. Right. It's this is a not. Minus. I think this is the way to find. This is good. This is the way. This is a not, and then that is the way to find the same number, yeah, the same position, but from the back. Nice, nice. Very, very nice. Okay, I'm gonna use this. This is good. This is very good. Very, very good. So this is just this is a little bit like chicken out because I want to do 2 lines, but anyway. So now this is Mr. Parkman's 2-liners. The use of tilde is need to be learned. Right? This is something you need to learn. All right, I'm gonna copy this, and what's the maybe it will be even faster runtime, right? Let's try try using this method. I think it'll be even faster. Float cannot be interpreted as, oh, he is in Python 2 as always. Did you run? I run it. Ah, I did not run. I run it myself. My version. I just adding a. It's unnecessary error. It's the same. It's the same. It's fine. All right. So that should be it. Right. Meet in the middle. Yeah, this is the same one. And we have a proof. Right? We have a proof. So it's not just like without proof. I mean, every time I consider this to be greedy, right? I consider this to be greedy because we're trying to figure out the best scenario, and we have a proof. It doesn't matter. It's like if you have a good argument, it's going to be good. Right, I'm going to upload this, and let's call it a day. It's a good day, good one. It's fast. I can go to eat. All right. See you guys tomorrow. Adios.